In this tutorial, we are going to graph secant and cosecant functions. So we're going to start with cosecant, and you can see I have a table here where x just gives a different variety of angles around the unit circle, and then we have the sine of those angles that is already filled out. So remember that cosecant of x is equal to the reciprocal of sine, so 1 over the sine of x. So if the sine of 0 is 0, then that means the reciprocal of 0 is 1 over 0 or undefined. So that means the cosecant of 0 is undefined. The sine of pi over 4 was root 2 over 2. Therefore, the cosecant of pi over 4 is the reciprocal of root 2 over 2. So 2 over root 2, which then we would rationalize our denominator. Multiplying across, we would have 2 root 2 over root 2 times root 2 is 2. 2 over 2 simplifies to 1, and therefore it is square root of 2. So the cosecant of pi over 4 is the square root of 2. If the sine of pi over 2 is 1, the reciprocal of that is 1, and then we can go through and fill these out pretty easily because all of these are basically the exact same as what we've already done over here. So now it's just a matter of what does this look like when we graph them. So if I'm graphing the cosecant of x, then that means at 0, right here where x is 0, I'm actually going to have a vertical asymptote because the cosecant is undefined. So at 0, or where x equals 0, we will have this vertical asymptote, which I tend to fill in with just a dashed line there. The cosecant of pi over 4 is the square root of 2. This is about 1.4, just so we can figure out about where that point should be. So pi over 4 should be up here, around there. The cosecant of pi over 2 is 1. The cosecant of 3 pi over 4 is the square root of 2, so again, that's about 1.4. The cosecant of pi is undefined, so again, we would have a vertical asymptote here, where x equals pi. Then at 5 pi over 4, the cosecant is negative root 2, which is about negative 1.4. The cosecant of 3 pi over 2 is negative 1. The cosecant of 7 pi over 4, again, is about negative 1.4. And the cosecant of 2 pi is undefined. So we would finish that up with a vertical asymptote. So the way that these connect is that this is going to basically curve up and open up. It looks kind of like a parabola that opens up. And then down here, it's going to look like a parabola that's opening down. And both of these ends approach but never cross these vertical asymptotes. So this is the graph of the cosecant function. And what helps me in actually recreating this is considering how we would graph sine. Typically, we would graph sine by saying, okay, if we're talking about the parent function, the amplitude is 1, so these are going to be labeled that way. And then how I've shown you is that we start with 4 tick marks along that x-axis. The period is 2 pi, and then we can label based on that. So each line is pi over 2, making this 3 pi over 2. If we were graphing sine, what we would do is we would start on the midline, and then we would go up to make a maximum, back to the midline, down to the minimum, and back to the midline. This is again for the sine function. So the cosecant, which is the reciprocal function, basically that means that anywhere that you had a point from sine that was on the midline, that is now going to turn into a vertical asymptote. So here, and here, and here. And then the point that's above that was the maximum of your sine curve, now it's going to be basically the bottom of that shape that looks parabolic, opening up. And then this point down here, which was below that midline, is going to be where it opens down. It'll be the maximum of that opening down part. So if you can just kind of think about how you would graph sine, you'll be able to then graph cosecant. So let's do the same thing for secant. I've already filled out the cosine of all of these angles. So therefore the secant, since secant is the reciprocal of cosine, well, the reciprocal of 1 is 1. The reciprocal of root 2 over 2 is root 2. The reciprocal of 0 is undefined. We would have negative root 2, negative 1, negative root 2, undefined, root 2, and 1. So that means the secant of 0 is 1. We're going to have a point here. The secant of pi over 4 is about 1.4. The secant of pi over 2 is undefined, so this would be a vertical asymptote. The secant of 3 pi over 4 is about negative 1.4. The secant of pi is negative 1. The secant of 5 pi over 4 would be down here. 3 pi over 2, you would have a vertical asymptote. 7 pi over 4 would be about 1.4, and then the secant of pi would be 2. So again, this is going to look like this, and this is a full period of the secant function. So I should have mentioned that before regarding cosecant. With our cosecant graph, this is one full period. So the period for cosecant for the parent function is still going to be 2 pi. Obviously, this could be adjusted because you have one full, basically what looks like a parabola opening up and then one full one opening down. You can see that you have the same thing here. Now these are split, but that's okay. The period is still going to be 2 pi. So again, I would think of graphing this the same way that I would graph cosine. So if I'm graphing the cosine parent function, then thinking about what starts on the midline and what doesn't can help us to graph the secant function. So I can graph this. Again, if I were graphing cosine, it would start at the maximum here off the midline. Then it would go down, and it would go like this. So in order to graph secant, anywhere that you have a point that was on the midline, that is now going to turn into a vertical asymptote. And then these points will remain where they are, and they would open up like this. So this would be like a parabola opening down, or it would look like one, and then these ones would open up.